Hey everyone, Mr. Phil's avatar here with another devlog update. Yesterday, I'm covering the resolution of the star rendering bug and a cascade of visual data preservation issues for Stellar Throne, my 4X strategy game. For context, I'm building this with Godot for the UI client and Zig for the high-performance simulation engine. After Monday's comprehensive parity testing work, Tuesday revealed that while the simulation data was correct, the visual presentation layer had some critical gaps. The big picture. I had validation showing that Empire resources, fleet positions, and planet populations were calculating correctly in both engines. But when I actually played the game after running turns through the Zig backend, stars weren't rendering with the right colors, planets were missing their visual properties, and entity names were disappearing entirely. The day started by finishing the star rendering investigation from Monday night. The problem was a type serialization mismatch. In Godot, star types are represented as integer enum values, 0 for red dwarf, 1 for yellow star, 2 for blue giant, and so on. But when I serialized the star data to JSON for the Zig engine, these enum values weren't being preserved correctly. The Zig code expected string representations like red dwarf or yellow star, but it was receiving integer values. When Zig tried to deserialize these integers as strings, the type information got corrupted. Stars would end up with invalid or default types, which caused the rendering system to display them incorrectly. I fixed this by adding proper enum to string conversion in the Godot serialization layer. Now when star data flows from Godot to Zig, the star type field gets converted from an integer enum to its string representation. When the data comes back from Zig to Godot, the string gets converted back to the correct enum value. Stars now render with the right colors and visual properties. But that fix revealed another problem immediately. Planets also have visual properties that weren't being preserved. Each planet has an orbital angle, an orbital speed, and a visual size that determines how it's displayed in the star system view. After a turn through the Zig simulation, all planets would reset to default orbital positions and sizes. This was happening because the Zig simulation layer doesn't care about visual properties. It only tracks gameplay-relevant data like population, resources, and production. The orbital angle and visual size aren't part of the simulation, they're purely cosmetic. But when I serialized planet data to Zig and back, these cosmetic fields were getting lost. I fixed this by extending the planet serialization to include the orbital fields. Now when planet data round trips through the Zig engine, it preserves orbital angle, orbital speed, and visual size. The Zig code doesn't use these fields for any calculations, but it passes them through unchanged so the Godot rendering layer can display planets correctly. Then I hit a more fundamental issue. Entity names were disappearing. Stars, planets, empires, and fleets all have names that are displayed in the UI. But after processing a turn through Zig, everything would lose its name and show up as unnamed or unknown in the interface. This was a serialization gap. The name fields existed in the Godot data structures and were being sent to Zig correctly, but the Zig structs weren't serializing them back in the output JSON. The Zig simulation would process the turn, generate the new game state, serialize it to JSON, and send it back to Godot, but the name fields were missing from that return data. I fixed this by ensuring every Zig struct includes name serialization in its toJSON method. Star names, planet names, empire names, and fleet names are now explicitly included in the serialization output. The Godot layer receives complete data with all the display information intact. But there was one more critical bug hiding beneath all these visual issues. Fleets were losing their ship composition data. In Stellar Throne, fleets aren't just a single ship count. They contain multiple ship types with different capabilities. A fleet might have 5 destroyers, 3 cruisers, and 2 carriers, each with their own health and combat stats. When I serialized fleet data to Zig, the ship composition was being sent correctly. But when the Zig simulation processed fleet movement and combat, it would only track the total ship count. The individual ship types and their stats were being discarded. When the fleet data came back to Godot, all ship type information was gone. This was a major bug because ship composition affects combat outcomes, movement speed, and maintenance costs. I couldn't have the Zig engine discarding this data. I fixed this by extending the Zig fleet struct to include a proper ship composition array. Each fleet now stores a list of ship groups, where each group has a ship type, account, and health percentage. When the Zig simulation processes fleet actions, it preserves this composition data. When it serializes fleets back to Godot, the full ship breakdown is included. Related to fleet movement, I found another bug where fleets would park themselves at the exact center of their destination star after completing a journey. This looked wrong visually. Fleets should orbit around stars, not sit on top of them. The issue was in the arrival position calculation. When a fleet finished traveling to a star, the code would set its position to the star's coordinates instead of calculating a proper orbital position. I fixed this by adding arrival positioning logic. When a fleet reaches its destination, it now calculates an orbital position based on the star's location and assigns itself a parking orbit. Fleets now arrive at stars and take up realistic positions around them instead of clustering at the exact center point. The final fix of the day was cleaning up the Zig unit tests. The tests were failing because they were trying to import Godot-specific modules that don't exist in the standalone Zig build environment. I made the Godot imports conditional. They only load when building the shared library for Godot, not when running the pure Zig unit tests. Now the test suite runs cleanly in both contexts. Let me give you the technical breakdown. Tuesday produced 8 commits. The star type serialization fix modified 3 files with 47 lines changed. The planet visual preservation added orbital field serialization across 2 modules with 32 lines. The entity name preservation touched 4 Zig structs with 69 lines of serialization code. The fleet ship composition fix was the largest change, adding 143 lines across 5 files to properly track ship types through the simulation. The fleet parking fix added 27 lines of orbital positioning logic. The unit test cleanup modified the build configuration with 12 lines of conditional imports. Current status: the Zig simulation backend now preserves all visual data correctly. Stars render with the right types and colors. Planets maintain their orbital positions and sizes. Entity names display properly in the UI. Fleet ship compositions survive simulation processing. Fleets park in realistic orbital positions. Unit tests run cleanly in both Godot and standalone Zig contexts. This was critical work because the dual engine architecture can't just be mathematically correct. It also has to preserve the player's experience. Players don't care that the underlying simulation is 52 times faster if their stars are the wrong color, and their fleet names disappear. These fixes ensure the performance improvement is completely invisible to the player. Next steps: stress test the visual preservation with longer game sessions. Add automated tests that verify visual data survives multiple turn cycles. Profile the Zig engine to see if there are performance bottlenecks in the serialization layer, and start thinking about how to leverage the validated Zig backend to add more complex simulation features like diplomacy and trade routes. That's the development update. Check out MrPhilGames.com for more. Thanks for watching.